Solving quadratics, we are looking for two numbers that add and times, two numbers that add to make 2, times to make minus 15, 3 and 5 are the numbers I want. To make this minus, one of these has to be negative. If I start on minus 3 and I come up 5, I end up on 2. So my two brackets are x minus 3 and x plus 5 equals 0. So I say either x minus 3 equals 0 or x plus 5 equals 0. So therefore in this case I get x equals 3, and in this case I get x equals minus 5. Simplifying with algebra. 3 times 4 is 12, a to the power of 3 times a to the power of 6 is a to the power of 9 because we add powers, and we get b to the power of 6. So, solving simultaneous equations and then using that to find an answer. So I know that from shape 1, 4x plus 6y is equal to 94 because the perimeter is all four sides added up. This equation, I find that I've got another y plus 4 here and another x plus 6 here. So in total I have 2x's plus 2y plus 4 plus 6 is 10, and again 20 equals 56. I'm going to take the 20 over so that I have the same setup here. So I have 2x plus 2y equals 36. I'm going to solve these simultaneous. I'm going to double the second equation. So I'm going to get 4x plus 6y still equals 94. And I'm now going to get 4x plus 4y equals 72. Same sign in front of these, so I'm going to subtract, which gets rid of my x's, and I get 2y equals 22. So y equals 11. I'm going to put that back into my first equation. So I get 4x plus 6 lots of 11 equals 94. So 4x plus 66 equals 94. So 4x equals 66 away from 94, which is 28. So x equals 7. Now the question asked me for the area. So rectangle A, the area is found by 2x times by 3y. So we get 2 times 7 times by 3 times 11, which I got 14 times 33. So 14 times 33. So 33 times 10 is 330. 4 32s. Let's just use the method. 4 3s are 12. 3 1 is 3 plus 1 is 4. Carry the 0. 3 4s are 12. 3 1s are 3 plus the 1 is 4. So we get 462. I think that's wrong, isn't it? 300. Nope, 462 for the area of the first one. And then for the second one, we have an area which is found by x plus 6, which is 13, times by y plus 4, which is 15. So we get 13 times 15, which is 195 centimeters squared. Question 11, histograms. Calculate how many telephone calls were made to the computer helpline during the Friday evening. So to find the frequency, group width times by frequency density. So this bar is 2 times 10. So we have 20 in this bar. This bar is again 10 but times 6. So we have 60. 10 times 10 we have 100. 10 times 4 we have 40. 10 times 2 we have 20. And in here we've got 20 times 1, which is 20. Add those numbers together, we get 250. Calculate an estimate for the percentage that lasted longer than 3/4 of an hour. Well, 3/4 of an hour would be here. So we can take all 20 of these, and we can assume half of these were longer than 45 minutes. So we have 30 calls out of a total of 250. And then times that by 100 to get it into percentages. We can cancel those zeros, and we find that that comes to 12% in total. Estimate the median length of a telephone call. So there were 250 people contacted, so 125 would be the median person. Now the 125th person is going to come in this group here. We need to work out how far across this group they would be. So there are 100 people in this group of 10 here, which means every one person is 0.1 minutes after the next person. So if we had 100 people lined up in here, we'd be on 20.1, 20.2 all the way through. Now the 125th person is the 45th person in this group. So they are the 45th person in that group. So that is, they are 45 times 0.1, so they are 4.5 minutes into this group. So that means they would be 20 plus 4.5, so they are 24.5 minutes into the group, so their median value would be at 24.5 minutes. Express that as a fraction, so we're going to let a equals 0.3464646. I'm going to times this by 100, and I'm going to keep the equals in the same place, so that the decimal point in the same place, sorry, so I can see them matching up. So I get 34.6464646. When I subtract now, I have 99 lots of A. All of these and these are going to disappear, and I'm left with 34.6 minus 0.3, which is 34.3. Take the 99 over, I get 34.3 divided by 99, times by 10, so I get rid of the decimal point, and I get A equals 343 over 900. Simplify in thirds, I'm going to use FOIL, so I get 7 minus 5 root 2, and I'm using FOIL because it's a squared, so there's two brackets. First, 7 times 7 is 49. Outside, 7 times minus 5 root 2 gives me minus 35 root 2. Inside, I get another minus 35 root 2. And last, I get 5 times minus times a minus first, which gives me a plus. I get 5 times 5, which is 25. And I get root 2 times root 2, which is 2. So I'm going to put that as in brackets by there. So I now have 49 plus, and this would be 50. So I get 99 minus 70 lots of root 2. Question 14. If I want to estimate the acceleration of a curve, I go to the point 1.5, which is here, and I draw a tangent as close as I can to that curve, and then to find the gradient of that tangent, I use the increase in y divided by the increase in x that we use to find the gradient of any line. So my increase in y is from 4 right the way up to 10, so that is 6. My increase in x is from 0 to 3, so that is 6 divided by 3, so I get an acceleration of 2 meters per second squared. And that is the acceleration. You will be given quite a lot of tolerance in that because it depends on how you've drawn your tangent. Trapezium rule, so the formula is h over 2 times by y0 plus yn plus 2 lots of y1 plus y2 in this case. H is how much this is going up each time. So I get 3 over 2 times by the first y value, so when t equals 0, I get a 0. When t equals 9, I get a 0 again, plus 2 lots of, when t equals 3, I get 8. And when t equals 6, I get 5. So this becomes 3 over 2 times by 13 times 2, which is 26. So I can do 3 times 26, which is 78, divided by 2, which is 39. So the answer is 39. Question 15. I'm going to answer this one using a tree diagram. So I've got the options of odd and even, and then a second ticket could be odd or even again. So if my first ticket is odd, I get a probability of 10 out of 20. My first ticket being even is also 10 out of 20. On my second ticket, the first one's already gone, so the chances of an odd again this time, there are only 9 of them out of 19. There are still 10 even tickets out of the 19. If the first one is even, I'm down to, well, I've still got the 10 odd, but I've only got 9 even to choose from this time. So the combination odd is 10 times 9, which is 90, divided by 20 times 19, which is 380. The combination odd even is 100 out of 380. The combination even odd is 100 out of 380. And then the combination even is 90 out of 380. The question says one of the tickets drawn is even and the other is odd. So it could be this one or it could be that one. So my final probability, 200 out of 380. Find the probability of at least one of the tickets is odd. So that encompasses all 3 of these. So I have 90 out of 380 plus 100 out of 380 plus another 100 out of 380. So I end up with 290 out of 380 as my probability.